Hello friends, welcome back. From past few tutorials, we are learning about physics concepts. We are learning physics concepts like we have seen position, velocity, acceleration. We have seen gravity, deceleration, right? And we have seen how these position, velocity, acceleration, deceleration, and gravity vectors are helpful for movement of the game objects. As we are discussing, most of the time we are discussing till now about movement of the game objects. Now as we are discussing physics, we also need to discuss about few laws which are really important laws which govern the motion, how the object move in the world. So Isaac Newton has observed how objects move, how objects behave in the real world. Isaac Newton has written few laws. Those are known as Newton's laws of motion. They are the broad information, I can say broad observation of movement of objects in the real world. Those are known as Newton's laws of motion. The first law says that the object at rest tends to stay at rest, that is forever. You have an object, let us take you have a car, you parked a car at a parking lot. Let us take you have parked a car at a parking lot. Then this car is now at present in a rest, right? It is not moving. It will be always in rest unless an external force acts on it. That is what Newton says. That means if you come after 10 years, if you come after 1000 years also, if nobody moves this car somewhere else, if there is no external force acts on this car, then this car will be always staying in that parking lot. Understanding? That means any object in the space or in this world, if it is not acted by an external force, then it will stay in the same state as it is. The object, what is the first law? The object at rest tends to stay at rest. The object in motion tends to stay in motion forever. What Newton says means, if an object is moving, if it is in a state of motion, it will be always moving. It will be always in motion until and unless some external force acts on it to change its state. Now let us take an example. Let us take so that you get a clear idea. Let us take you have a ball and you throw it. Now what you are doing means you are applying some force on an object, that is a ball, to move in this direction, right? Now what happens actually, when you throw this ball, it will jump like this and come down, hits the ground, again it will jump like this, right? It will jump like this, will jump like this, will jump like this, goes, and at last it will come to rest state. It will come and to stop. It will come to a rest state, right? It will not move further. Now, but Newton said that if an object in a motion tends to stay in motion forever, until and unless an external force acts on it. That means here the object is in motion, it has came to rest state. That means there are some external forces acting on it to make the object come to the rest state. Now when you throw a ball, there are a lot of different forces acting on that ball. That means there is a force called gravity acting on it to make the object move downward. In every step, you can see that there is a gravity acting on it to make the object go down. There are some other forces are also acting on that object. That means when the ball hits to the ground, there is a slight impulse force acting on it, an instant force, we say instant force acting on it to make the object go up. Then again here the instant force is acting on it, here again the instant force is acting on it, here again the instant force is acting on it to move it up. The gravity is pushing down, instant force is moving it up. So there are few forces acting on the ball so that the ball goes slowly down and down and down and down and down. Understanding? And also if an object is moving in this direction, also the object is moving in this direction, right? The object is moving towards right. There is an opposite force acting continuously, that is known as the friction force. There is a force which is acting in opposite direction so that the object comes to the rest. So there are many forces acting on an object in the real world. If it is moving, definitely it will come to the rest state. If an object in the rest state, it will be always in the rest state until and unless if some external force acts on it to make it move further. Understanding? That is what the Newton said. The object at rest tends to stay in rest, an object in motion tends to stay in motion. I hope you guys have understood. Let us take, if it is a space, if there is no if there is no external forces acting on this ball, then what happens means the ball will be always moving in this direction forever and forever and forever. As the different forces acting on it, it will eventually come to the rest state slowly. Now there is another law, that is second law, or Newton's second law of motion. Motion means movement. Now what it is, it says that force is equal to mass into acceleration. Now what is the meaning of that? Before we understand, we need to understand what is mass. We already know what is acceleration. Acceleration means what? Change in velocity over time. We know that acceleration affects the velocity. It changes the it scales the velocity, descales the velocity, or changes the direction of velocity. That is what the acceleration does. Now we are going to understand what is mass, because that is the most important concept here to understand what is force then. Now mass indicates number of atoms in an object. You have lot of objects around you, even you are an object, I can say. Now let us take, you have a ball. Now ball is going to made of many atoms. There are many atoms, you can say lakhs of atoms present or crores of atoms present in one object. An object is made of many atoms, guys, atoms. Now the number of atoms indicates the mass of an object. Let us take a simple example that you have a small ball made of sand. The total number of sand particles that indicate that the mass of that ball. Understanding? Now unit of mass is in kgs. We actually measure in kgs. Then we have to understand another concept known as the weight. That is an important concept. We have to understand what is the weight. Weight is actually mass into gravity. We know that the gravity is acting on every object in the real world every time. Now how do we calculate the weight of an object? Now if you want to calculate the weight of an object, you have to multiply the mass, that is total number of atoms, multiplied by the gravity. Mass into gravity gives the total weight of an object. It's an important concept, try to understand. Now if you have a mass, that the sand, let us take a ball made of sand. Now there is a gravity acting on each and every atom. So what we do, we take the total number of atoms, we take the gravity, if we multiply, we get the what is the actual weight of that ball made of sand. Understand the difference between what is mass, what is the weight. I hope you guys have understood. Next we have to understand the concept known as inertia. Now inertia means the resistance to motion. Now this resistance to motion is actually directly proportional to the mass. Let us take an example that you have a small stone. Let us take, you have a small stone, and if you apply a force, then you need a very small force, or you can say a very less force to move this object, right? Right or not? Very less force you need. Now let us take, you have this much big stone. Then if you have to move this object, you need a very big force you need to apply, right? The inertia indicates the resistance to motion. Resistance to motion means if you are pushing an object, if you are pushing some object, this object tries not to move. That means whatever the force you are applying, it will give an opposite force to stay in rest. It tries to stay in rest. That is known as resistance to motion. So remember that what is mass, guys? Mass indicates number of atoms in an object, whereas weight indicates number of atoms in an object multiplied by the gravity. whereas inertia indicates resistance to motion, is directly proportional to the mass. Directly proportional to the mass means if mass is smaller, then it will be having less inertia. That means you can very easily move it. Whereas the mass is bigger, that means if it is made of lot of atoms, then it has more inertia. That means it is difficult to move this object or any object which is made of more atoms, you can say. So directly proportional. I hope you guys have understood what is the meaning of directly proportional to mass. Now let us come to this place. Now we understood what is mass. What is mass? Number of atoms in an object. Good. Now what is the Newton's second law says? Newton's second law says that force is equal to mass into acceleration. That means if you have an object made of some mass, let us take you have an object with some mass. If you want to accelerate it this much amount, then you have to apply this much force. That is the meaning of Newton's second law. That means if you want to move an object, the force should be mass into acceleration to give this much acceleration. Now unit of force, you can see the unit of mass is kg that we have seen here, and we also know unit of acceleration is meters per second square. So kg multiplied by meters per second square is the unit of force. Usually what we do, the force in books we usually say unit of force is Newton. Actually 1 Newton or the Newton means you can say kg into meters per second square. You should understand Newton means Newton tends to kg into meters per second square, guys. I hope you guys have understood. Similarly, you can see here weight is a force. So weight is calculated in Newton. Gravity is a force. It is also calculated in Newton. Understanding? So force has the unit of Newton. And what actually the meaning of Newton? Kg into meters per second square. And what is force? Force is equal to mass into acceleration. We are going to understand the second law in detail little bit later. Step by step we get some information. I hope you guys have understood what is the second law says. Now there is third law of motion. Newton's third law of motion. That is, every action has equal and opposite reaction. What is the meaning of that? The meaning of that is, if you have an object, like you have a car, let us take you have a car or a bus or some game object or some object like table. Let us take you are trying to push this object in this direction. That means you are exerting a force on this object or on this car to move it in this direction. But you should also remember that there is an equal force acting on it, equal and opposite force acting on you, so that the object tries to stay in rest. Now let us take if this object is not there, let us take if this car is not there and you are trying to push, then what happens means you just fall down. Correct or not? You just fall down. So that means you can think like the car or the other object is having an equal force, is acting on you, you can say, a force acting on you, so that there will be an equilibrium. If your force is more, then the car will start moving in this direction. That is what the third law says, that every action has an equal and opposite reaction. Also you can say that if this is a wall, if you throw a ball, let us take you throw a ball in this direction, right? Then when the ball hits in this place with some force, we know that there will be an equal and opposite force so that the ball comes back, right? Let us take some other example. You have, let us take the water is flowing like this. If the water is flowing like this, then the water molecule will be having some force so that it is moving in this direction. Correct or not? If there is no force, it will not move. That we know that. So it is moving in this direction. Let us take you have built a dam, right? You have built a dam or you have a wall over here. Then as the wall is present, we know that the water molecules will not move further. They will stop here. Why? The reason is an equal and opposite force is acting on them so that the water will not flow. Let us take if there is no wall. If there is no wall, according to the Newton's Newton's first law, then object in motion tends to stay in motion. Of course, they have to move. Then as there is a wall, there is an opposite force acting on them so that they will not move further. That is the wall's force, that is known as molecular force. Actually, each and every molecule on the wall are also acting in an opposite direction so that the water does not flow in this direction. Understanding? That is what Newton's third law says. So we have understood what is Newton's first law. Newton's first law of motion. The object at rest tends to stay at rest. Object in motion tends to stay in motion forever unless and until an external force acts on it to change its state. And the second law says force is equal to mass into acceleration. And the third law says every action has an equal and opposite reaction. Good. And we have understood what is a mass. Mass means number of atoms in an object, and weight indicates mass times gravity. And the unit of weight is Newton, because weight is also force. The inertia indicates resistance to motion and is directly proportional to the mass. So hope you guys have understood all the concepts. Let me select this and delete. Now what we do, we understand Newton's second law of motion, and we also understand how do we implement that in our code, how do we implement that in our games or simulations. Now what Newton's second law says, force is equal to mass into acceleration. Now we have to understand this clearly. Now what I do, I just move the mass in this direction or here to the left hand side. Then the formula becomes force divided by mass is equal to acceleration. Or I can say that acceleration is equal to force divided by mass. Now what is the meaning of that? If you have a mass of some object, you want to move this with some acceleration, then you have to apply this much force, and you can think like this. You can think like what this says is acceleration on an object is equivalent to total force or the sum of forces acting on an object divided by the total mass of an object. That is the meaning of this formula. A is equal to force by m. Now let us take you have an object. You have an object. Then you are applying some force in this direction, some force, so that it should move in this direction, right? If you are pushing from this side, it will start moving in this direction, correct or not? Let us take somebody else is pulling in this direction. That means somebody is applying a force in this direction. Then you should tell me in which direction the object start moving. Simultaneously, at a time, this person is pushing and this person is pulling. Then what happens, guys? You can say that the resultant movement of this object is, this one is let us take A vector, this one is let us take B vector. If you add these two vectors, you should arrange it in the tail and head format, right? You have to arrange both of them in the tail and head format. Now if you see, they are already in the tail and head format. So the resultant force is going to be like this, or the resultant vector A plus B, you can say A plus B vector is going to be like this. So what happens means the game object or any object, now it is going to move, or this object is going to move in this direction, my friends. Understanding? That is what the acceleration says, that if you have a force A, if you have a force B, then the resultant force on this object is going to be the sum of forces, that is A plus B, divided by the mass of an object. Divided by the mass of an object. Maybe the mass is 1, or maybe the mass is 10, maybe the mass is 20. Maybe let us take this object is made of 10 molecules, made of 100 molecules, maybe made of 1000 molecules. Understanding? So here, that is the meaning, guys. So this is going to be the acceleration. I can say ACC. Let us take acceleration. I can say some term acceleration. Acceleration is equal to some force divided by the mass. So how do we implement this in our code? So if you want to implement this in our code, what we do means whenever we want to move an object, first we identify what are the forces or how many forces are acting. There might be thousands of forces acting on an object. Then what we do, we take the sum of all the forces. We take sum of all the forces, that is going to be some force, and we divide it by mass. That will give us the acceleration. And then we know that what we have to do, we are going to use this acceleration, add it to the velocity. Then what we do, we apply that velocity to the position of the object so that the object starts moving. Simple. I hope you guys are understanding. This is how we perform. So remember the steps. Steps are most important. The first step, what we do? First step, we identify all forces, right? Identify all forces acting on the object. Then what we do? We take sum of all forces acting on the object. Then what we do? We divide the sum force or the resultant force, you can say, by mass of the object, right? Then what we do? We assign acceleration by the result of some force or the divided by mass. That is what we assign to acceleration. Then what we do? We say velocity plus equal to acceleration. Then we say position plus equal to velocity. Simple. These are the steps that you are going to perform to move an object. Simple. This is how it works, guys. In the next tutorial, we are going to see how we perform this step in the code, and we step by step learn how it is going to be implemented in the program. So let us take, you have an object here and there is a force acting on it. Let us take this one is F1, this one is F2, right? These are the force we have identified. Let us take, we have identified this one, and we have some mass. What we do? First we calculate the sum force. Sum force is equal to F1 plus F2. We calculate. Then what we do? We apply the acceleration by some force divided by the mass of the object, that is maybe m, you can say. Then we take the velocity vector, we add acceleration to it, then we say position plus equal to velocity, so that the object start moving, and you can say it's meaningful, right or not? You can see here, we know that the acceleration changes the velocity, we are applying that, and the velocity changes the position, we are applying that, and the force is the one which accelerates. That's the meaning of Newton's second law. Force is equal to mass into acceleration. So for this tutorial, I think this much is enough, guys. So watch this video again and again until you understand each concept that I have explained in this tutorial. So in the next tutorial, we practically see. Thank you, guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.